this is the last portion of our chapter, indifference by division of wavefront. So the next one is indifference by division of amplitude. So here in this class we are going to discuss Fresnel's two mirror arrangement. Okay. The two portions in the last class we had discussed biprism. So why Fresnel devised two methods for describing the phenomenon of indifference is that it was Young that showed the indifference phenomena for the first time. And it is known as the Young's double slit experiment. And even though the phenomena of indifference and wave nature of light was proved by Young through this experiment, there was a objection raised from various corners that the bright fringes are obtained due to some modification of light by the edges of the slit, and it is not happening due to true indifference. And Fresnel was a scientist who tried to give a confirmation of the indifference of light, which was put forward by Young. And he was actually an engineer, and his name is Augustin Fresnel. And his life period is between 1788 to 1827, and he devised many new variety of experiments validating the indifference phenomena. And the one important among them is biprism experiment and Fresnel's double mirror arrangement. Okay, so here in this class we are going to discuss Fresnel's two mirror arrangement. From the name itself, it is clear that in this experiment there are two mirrors, so we'll discuss it in the live board. Okay, from the name itself it is clear. So this experiment consists of two mirrors which are slightly inclined to each other. Okay, two mirrors. The angle between the two mirrors is what? Theta. And you know, we are having the polished, I'll do it like this. Okay, the polished surface, this is the unpolished surface, the other one is the reflecting surface. The surface with line does not reflect, and the surface without lines reflect, that you know already. And this is again the unpolished surface, right? The other one is the polished surface. And you're going to name this as this is named as M1, and this point of intersection is named as M, and this region is named as M2. Right, and these are two mirrors, and we are having a screen here. We are having a screen here. Yes, screen is a bit tilted, right? So we are having a screen here, and suppose we are having a monochromatic source of light at this point, S be the monochromatic source of light, and suppose the light from this monochromatic source light from the monochromatic source, suppose it hit the mirror M1 at this point, and it reaches this point on the screen, and again the light ray reaches this point of intersection almost. Okay, and it reaches this point, suppose. Again, this ray can get reflected along this direction. It can also get reflected from this point to this point also. Okay. And it can also get, light may hit this point and it can reach here. Okay, so I can name this areas as, this is what, I can name this as A. I can name this point as B, this point as C, and this point as D, right? And normally we'll get the indifference pattern in the region BC. Okay, light may reach from the mirror M1M. The light, I can show the ray path also. This ray get traversed in this direction. The second ray can take two paths, either this one or this one, and the third ray is this one. So in this region BC, both of this light interfere to obtain the interference pattern. And I can assume it in a different way. So for a person standing here, he'll be having a feeling like this two light rays can be extrapolated. Suppose I can extrapolate this like this way. Okay, I can extrapolate it like this way. So I'm going to redraw it. I need this much. And similarly, you can extrapolate this ray path also. So here I can, for a person standing here, this light ray is observed to be emanating from this two sources named as S1 and S2, and these two sources S1 and S2 act as the coherent source, and all these points, that is S1 and S2, all lies on the, cannot draw it clearly here. Okay, all these points actually lies on a circle. I can see it almost forms a circular path, and it forms, it is it is at the center of a, and this M represents the center of a circle, and then I can name the radius of the circle to be R. I can name the radius of the circle to be R. Capital R is the radius of the circle, and this angle is theta. Angle between the two mirrors is theta, means I can say the angle S1, angle S1, S2, angle S1, S2 is also theta by the geometry of this problem. Geometrically, the angle between the two mirrors is theta. This is theta. Okay, this is theta, means this angle S1 S, that is S1 S S2. This angle will be theta, and this angle will be, and in this region this angle will be 2 theta. Okay, this angle will be 2 this angle will be 2 theta, right? And if I'm taking this arc S1 S2, what I'll get? Arc S1 S2, angle is equal to arc by radius, or arc is equal to angle into radius. Angle is 2 theta and radius is capital R. Okay, so in the region, in this region we'll get the, in this region we'll get the interference pattern by the Young's double slit, Fresnel's two mirror arrangement. The region BC will get the interference pattern. So this is all about the Fresnel's two mirror arrangement, and S1 S2 arc is equal to 2 theta r is the angle, r is the radius, and 2 theta is the angle subtended by the arc. Okay, so hope this is clear for you. This is again a important question which is generally asked as a short question for your exam. Okay, this is what is shown here, and this angle is 2 theta. These are two mirrors in the region BC. You get the interference pattern, and S1 and S2 actually S are the points on a circle having radius R and center M. Okay, so we'll discuss one problem dealing with this portion. That is, what must be the angle in decrease between two Fresnel mirrors. You just note the point. If it is Fresnel mirrors, means you'll have to use this 2 r theta for D in order to produce fringes 1 millimeter apart. If the slit is 40 centimeter from the mirror intersection and the screen is 1.5 meter from the slit, and a wavelength of the light is given, beta is given, right? Fringes is 1 millimeter apart, means fringe width is 1 millimeter, radius is given. If the slit is 40 centimeter from the mirror intersection, that is, these are the sources, these are the sources S1 and S2, and it is at a distance 40 centimeter from the intersection of the mirrors, that is capital M, and this distance between M and S2, that is actually the radius of curvature of this circle. Okay, that is given in this problem. It is a bit twisty, and it is written as, if the slit is 40 centimeter from the mirror intersection and the screen is 1.5 meter from the slit, and the distance between the slit and the screen is capital D, that is 1.5 meter, and using the equation beta is equal to lambda D by D, what I have to get is D, and we know what is D. It is the arc S1 S2, that is the distance between the sources, coherent sources S1 and S2. It is actually the arc, and its value is equal to 2r theta. So I can substitute, instead of D, 2r theta is equal to lambda D by D. From that I can find the angle theta. Theta is equal to lambda D by 2r beta, and everything is given. Substituting this gives you the answer in radians. What you have to do is, we have to convert it into degrees by multiplying it by 180 by pi, which gives you 0.063 degrees. Hope this problem is clear for you. It is a simple question. Only thing you have to know is that D is equal to 2r theta. In the Fresnel biprism problem, D was actually what? D was a root of D1 into D2, or D was 2r mu minus 1, 2a mu minus 1 into alpha. And in this, D is 2r theta. That is only the difference. Okay, so these are the questions. What you have to do is, this is the last class of this chapter. So you are having some questions. You just go through this 1, 2, 3. In this page there are 8 questions. You just go through this questions and try to get the answers given here. If there is any doubts, you discuss between, and if it is not clear, you can come to me. So you'll have to submit this assignment by 30th of October, right? So you are having enough time left for submitting this assignment. You try to submit this assignment by 30th of this month. Okay, so I have discussed with your classmates, and they have given me a suggestion to give you assignments as you are in the wake of your 4th STEM examinations. Okay, so thank you. If you are having any doubts, you come to me.